As a homeowner, I'm always working on something. As a builder, I get to see what works and what doesn't.
Yeah, come on up here, Cole.
Yeah, let's take a look at how this comes together. I'm touching this and I'm not feeling any electricity coming through, so how do I know it's working? How do I know it's working? The idea of solar power as a solution for our energy needs seems impractical and even futuristic. Yet on today's show, you will see that not only is it practical, it's also affordable.
The sun is free, and on the farm we have solar electric fencers. The highway department has solar panels that run the interchanges. Solar made sense for central Missouri.
We've been here for over 30 years, and prices in everything is going up and will continue to go up. So for us to be able to save on our electric bill, and we know the rates are only going to keep going higher, we needed to do something now.
Well, Vaughn, I got to tell you, this is quite a structure. How did you get to this point in the process?
Well, Cole, there's a little bit of paperwork you got to do first. You got to file for a building permit. And we had to do a structural design, and then we had to do an electrical design for it. Plus, you got to submit an application to Enron UE. There's an interconnection agreement you have to submit with them and get their approval to build a structure. But after you do all that paperwork, then we get to the work here.
Yes.
And it starts right here with the foundation. I mean, any good structure's got to have a good foundation. So, first thing we had to do is get our backhoe here, and as you saw, we had to dig out for a footing here, and we then went down about 4 or 5 feet into the ground for our footing. We poured it with 4,000-pound concrete, and then we set a template here where we set our anchor bolts. As you see, there's 4 3/4-inch diameter anchor bolts there. So we set our template there, we poured our anchor bolts, and as you see here, we have 6 foundations here. We have 6 columns which support this structure. This is A50 steel, and we put in our anchor bolts here, and then we set our column structure here, and then from here we go up.
So the guys, when they're setting this up, they have to be very, very specific on where these points are going. Otherwise, this structure's not going to come together like it's supposed to.
Yes, when we first start, we have to set up our batter boards here with our string lines, so we get a nice square structure here, so we know where we place these anchor bolts, because the steel is fabricated at another shop. So we have to make sure our anchor bolts are in exactly the right place that are going to match it with the steel structure.
So if somebody misses a point on it, we could be in a little bit of trouble, might have to do some adjusting.
May have to get out the jackhammer. Yeah, that's right. We don't want to get out the jackhammer, so we want to make sure it's right the first time. I want to point out that these are hot-dip galvanized columns, because the structure has to last as long as the modules, and the modules will last for 30 to 40 years. So they're very long. They could last to 50 years. We don't know. They haven't been around that long, but they're rated, 30 or 40 years, could go out to 50 years. And so you got to have a structure that's going to last for 50 years too. So we've taken great pains to put a hot dip galvanized columns, as well as everything here is galvanized, which will last for more than 50 years. So we got the columns here, and then we go to our steel beam, which is again is a galvanized, it's high strength steel for our steel beam. And then from our steel beam, we have what I call the rails, or someone might refer to them, they look like a rafter, but they're really the rails. And these rails are galvanized, and they are what the modules are clamped down to. So they're clamped to those rails, and if you need to remove a module, you can. You just undo the clamp, and you can take out the module and replace it if, for instance, somehow it got damaged. But those modules are clamped to those steel rails, and we have designed this to be very modular. We can build this at any location. It can be built in Jefferson City or Eldon or Columbia or Moberly, wherever they may want a solar array. So our crew is very used to putting up this modular system, so we can put it together very quickly.
So when you put this plan together, the engineering plan, most of these things all come pre-drilled, the bolt systems come with it, you just put it's like a puzzle that you put together.
That's right. We've got everything planned out. There's all the pieces. We know how all the pieces go together. And we have high strength bolts there that we torque down so that they be very tight for the next 40 or 50 years.
So solar arrays have several different applications. You can be on a roof, you can be lower to the ground, or you can have a raised structure that serves multiple purposes. One, it's providing the power for his business, and then he also has a place to park his vehicles and anybody could use this as a break area, whatever you want to do.
Exactly, Cole. I mean, you can get very imaginative, and that's the key thing with solar energy. And we haven't had it around the modules, so you can get very imaginative on how you might want to mount your modules. The most traditional way is to mount them on your roof, on a south-facing roof. That's the most traditional way, but there's many other ways, like we're showing here today, where you can mount them up high, use it for a shade structure, or have the office workers or your own family can have a little picnic area out here, whatever you like. Plus, another big benefit when you get it up high, from a safety point of view, it's out of the reach of children or any animals or anything.
And it's going to last, and with all the galvanized, we're going to make sure that this thing's not going anywhere. It's going to stand the test of times. Change out panels in 30, 40, 50 years, and you're on for another 30, 40, 50 years.
Long time.
Or maybe even longer. That's correct. Well, Vaughn, what's the next steps? Once you have your structure up, where do we go from here?
Well, we're going to go up top side. Let's take a look at the modules. I mean, that's the reason we build the structure. The structure is really secondary, really, yes. But we're trying to build a platform that we can mount these modules on. So let's go up and take a look at the modules. Yes.
Well, Vaughn, I remember as a kid seeing solar panels go up on homes, and at that point in time, I always thought, man, those guys must be rich. They got solar panels, you know? So, but what I'm seeing these days is this is actually becoming quite popular. And it seems to me now, with the affordability and all the rebates, that this is solar power anybody can have, and that's pretty awesome.
That is awesome, and that's exactly true. The cost of solar energy has dropped very significantly, as well as there are new incentives which are there that the federal government is trying to encourage our use of clean, renewable energies in order to generate the electricity going forward into the future. We have issues with global warming and various things like that, so this is a very good answer to that.
Well, let's see how this works.
Okay. Yeah, come on up here, Cole.
Yeah, let's take a look at how this comes together. Yeah. Man, this is quite a structure. This is pretty awesome.
Nice and blue. I like that color blue, huh? A kind of sky blue color. I like that in a module, so it's very aesthetic.
Most of your home's heat is lost to the ceiling. Today I'm going to show you how to measure the R value of your attic insulation. All you're going to need is a measuring tape or a ruler. You may need to dig some of the insulation away so you can have it touch the bottom. In this case, you can see it's about 10 inches. We have cellulose insulation here, which is an R value of 3.7 per inch. Fiberglass, another common insulation in attics, is 2.6 to 2.8 R value, which R value is your resistance to heat. Adding attic insulation to your home is one of the most effective ways to increase the comfort and lower your utility bills. Often the cost is offset by local utility rebates as well. For more information, visit goenergylink.com.
Being here makes me smile a lot.
It's one place I don't have to worry about fitting in.
I learned how and why to make a difference.
Forum Christian Church, connecting, growing, living.
Wouldn't it be great if everything were free? You really can have free solar energy. With today's utility rebates and federal tax credits, solar energy can provide immediate cost savings on your utility bill and free electricity often in just a few years. So why you have to keep paying for everything else? Find out how you can get free energy from the sun today. Missouri Solar Applications, a shining solution.
Closed captioning brought to you by
on Lamone Industrial Boulevard.
Well, as I said, it looks like the panels go down pretty easily. It looks like you have a couple clamps here that they screw down.
Yeah, that's right, Cole. Yeah, we got clamp there. Those are called mid clamps, and these are the end clamps. They're a little different design. So you got end clamps, mid clamps, and then the final, of course, you have an end clamp.
Looks like it's pretty easy to go down, but I know the technology behind this isn't easy.
Yeah, this gets into space age type of technology. You know, when we had the first spacecraft took off, you know, how are they powered in space? They're powered by solar cell. The same type of solar cell you're seeing here is how they have powered the spacecraft for many, many years in space. So we can get into a little technical discussion here about how solar electric energy works.
I'm ready for it. I want to know how this all comes together and how we start getting electricity to this business.
Okay, great. What you see here is these are little cells. They're 6 inches by 6 inches. When I refer to a cell, it's like a battery cell. You know, on your battery for your flashlight, there's 2 cells, and they call them cells, D cells or C cells. You know, those are little batteries. And what this is, it's not a chemical battery. It's really a battery based on physics. So it's 6 inches by 6 inches, and as you see here, we have 10 cells along this way and 6 cells along this way. So there's a total of 60 cells that make a module, this module here.
So now this looks like glass, but this isn't glass, is it?
Well, yes and no. Actually, it is protected by tempered glass. This is a high-strength tempered glass, which is hail resistant, because that's one of all the questions you get, you know, what happens when it hails and is this going to wreck my panels? No, these are hail resistant modules. Now, that being said, an unusual weather event is covered by insurance. If there's a tornado or something like that, obviously you insure your thing, but any normal weather event is covered. These are hail resistant. So this is tempered glass, but what the cell is made out of is silicon. The same thing, it's a semiconductor, silicon is, and you see it, the same thing you see in the computer chip is a silicon cell, is a semiconductor, and that's how different signals move through your computers. This is just on a much grosser scale, a much bigger scale, you see a cell. And so this is a silicon, and it's a wafer. What they do, they make a silicon long, like a bread loaf. You know, it's kind of shaped like a bread loaf, like 6 inches by 6 inches, and they slice that bread loaf into very thin cells. So it's a wafer that is 100 microns in thickness. So they slice that bread loaf of silicon, shall we say, and then they set that cell here. And then there's wires. These are silver wires which are on that cell. Now, it's not just silicon. They put 2 chemicals in with the silicon, because silicon is not a conductor, it's a semiconductor. It doesn't move electricity. So you have to somehow give it a tendency for electricity to move, and you do that by adding boron and phosphorus in small quantities to the silicon. So when they melt the silicon down, because what is silicon? It's basically sand. You got to get it to very high temperatures, you melt it down. Silicon in liquid form, you add boron and phosphorus in a teaspoon of each, not exactly, but you add that in, you're basically baking bread,
right?
And then you're going to slice that bread, and then these are the cells. So when you add that boron and phosphorus, it gives a tendency for electrons to move, but they won't move, they're trapped in the, if you go back to physics, you know the atom, there's a nucleus of an atom, and then there's electrons that fly around that nucleus. And they're usually stable. They always stay with that atom, you know, that's how it is. But if you put boron and phosphorus in there, you create a tendency for those electrons to move, a tendency to move, but they won't move unless they're energized.
That's where the sun comes in.
The sun is the energizer bunny, shall we say. It's giving energy. So when it gets the energy to it, that's the photovoltaic effect, these electrons jump out of that cell and they're free, and they're going to travel someplace. They're going to travel over to this other atom and to the next atom. And when they travel to one area on this cell, actually where they're traveling to the bottom of that cell becomes negative. Where electrons travel to are negative, and where they left is positive. So what do we got? We got a battery, we got negative and positive. Now all we got to do is put a wire across it, and we got electricity.
And we're creating our power.
We're creating our power from the sun. And then when the sun stops, the electrons don't move, because there isn't any energy to energize them for them to leave the orbit around that particular atom, you know, around the nucleus, so it leaves that. So that's the basic principle in pretty simple words of how photovoltaic solar electric energy works.
So now to power a business, as we've been talking about, how does that all come together? I mean, we got electricity making here. How do you trap that? How do you get that to the house? And basically, I noticed that we have quite a few panels, so it takes a few to make that power.
That's right, it does. This array is going to have 56 of these modules, and 56 of these modules will be able to satisfy almost the entire electric needs of this business here for Bill Grott.
That's unbelievable.
all their electric needs are going to come from this array here. Now obviously if you use less needs, like for your home, then of course you would have a smaller array. They're called modules, sometimes referred to as panels, but to kind of play on words, they're modular. I mean, how much electricity you need, we just add more modules. We just add more modules.
This season of Building for Better Living brought to you in part by Mark Hall Cabinetry, where everything you imagine materializes. Steve's Pest Control. Now you have a friend in the pest control business. Slumberland Furniture. The way you live, the way you save.
If you came to Slumberland and said, I want this sofa, I want 1,000 of them, we'd give you one heck of a discount. That's called buying power. And with over 120 stores, Slumberland has the power to save you big money. That's why you can design rooms that look like this, or this, or this, at an amazing price. Slumberland's buying power turns into your buying power, and you get so much more for so much less.
Imagine style so eloquent that functionality is secondary. Imagine expert guidance and a process that's all about you. Imagine exceptional quality at a price you can feel good about. Imagine immense satisfaction. Mark Hall Cabinetry, where everything you imagine materializes.
A termite eating through the wall of my home. An infestation of ants crawling on my kitchen counter. A brown recluse spider about to bite my son. Roaches crawling in my cabinets.
If you've got a bug problem, don't call a psychiatrist. Just call me at Steve's Pest Control.
Now you got a friend in the pest control business, Steve's Pest Control.
Closed captioning brought to you by
on Lamone Industrial Boulevard.
I'm touching this and I'm not feeling any electricity coming through, so
That's
how do
good.
I know it's
That's
working?
good.
How do I know it's working?
Yeah, I mean, everyone looks at these things and say, is this producing electric energy? Well, I'm going to do a little demonstration here with help of Jeff Owens. Jeff Owens is the operations manager for Missouri Solar Applications. And Jeff has a device here which measures the voltage and amperage. So we're going to measure the voltage. And if we'll go back to just refresh your memory, I said each one of these generates about 1/2 a volt, each cell. We got 60 here, so 60 times 1/2 is 30 volts. And we have 12 hooked up here in series. So 12 times 30 should be over 360 volts we have here in DC power. And so Jeff's gonna, here, let me help you, Jeff, here. We're gonna put the negative and the positive on here. So we got that one connected there. And this one here, the positive, and the voltage. What does that say? 398 volts, almost 400 volts. So that's the voltage you're getting from these 12 modules hooked together. So all you gotta do is put a wire across that voltage and you're gonna get a lot of current flow.
Yeah, so it's outperforming what it's actually specified to do.
That's right. We had 30 times 12, 360. So we want to see over 360 volts, and actually it's outperforming what it typically does. We have a very bright, sunny day here, and solar energy is, kind of an average because, when you got a bright day, you're going to get a lot more energy than you will on a cloudy day. And we have a very bright day today, and we're getting a lot of energy out of these modules. As you know, when you work with electricity, there's a potential for shocks or things like that, or maybe even lightning. So you have to have a grounding system that can ground those particular shocks down to ground so no one gets hurt or doesn't hurt equipment or doesn't hurt people. So
I can imagine that this system, being high up like it is, if a storm were to roll through here, might get hit with lightning or something like that. So you have to have some sort of grounding system.
I just happen to have here what they call a Delta Lightning Arrestor. Lightning arrestor, which is like a surge protection device, you have on your computer at home.
Right.
But it's obviously made for much higher voltages and much higher amperages. And what we do, we install this On our combiner box, I'll show you the combiner box later, we mount it on the column down here. So if there's any high lightning strikes or any electric current fault, this prevents it from going into the building or traveling inside. It stops it right here at the array.
So it's a surge protector for the solar array.
Exactly. And then on the inside, we double it up. We have an AC, an alternating current surge protector too, on the AC side, because sometimes utilities don't like to say this, but they give voltage surges too, which can affect our equipment. So we protect you from the utility that its effect it might have here. And if for some reason this one might fail or something, we have an AC side for protection too. So we have AC protection and DC protection here.
And we mentioned weather. You know, today is a beautiful sunny day here in Missouri, but what happens when you have cloud cover? You know, does this solar power work?
Yes, on a bright sunny day it's gonna, and during the summer it's gonna generate its most energy. During the winter on cloudy days, obviously it's gonna be a less amount of energy because the energy it produces is proportional to the radiation that we receive from the sun. The radiation from the sun is obviously dependent on how many hours of sun you have in a given day, and of course the summer has many more hours of sun than in the winter, and it's dependent on how high the sun is in the sky to how intense that radiation is. As it gets lower in the sky in the winter, it's less intense the radiation, so you get a little less energy there. But we know, based on the National Weather Service in Columbia, Missouri, we know how much radiation we get here on average every year. For the past 30 years, they have records there, and that's what we base our performance criteria. So when Bill Gratz came to me and asked, well, how much energy is this going to produce in a year? I can confidently tell him it will produce 15,000 kilowatt hours a year based on the Columbia weather data. And that takes into account bright sunny days, cloudy days, days we had snow, or days that rains, whatever. It takes all that's averaged in to produce 15,000 kilowatt hours a year. If this array was in the desert in Arizona someplace, it wouldn't be 15,000 years of great. It might be 20 or 25,000 kind of thing. But here in Missouri, central Missouri, we know it will produce 15,000 based on our weather here.
So there's a lot that goes into this, a lot of research that takes place, and it sounds to me like you guys have done your homework on all this application.
Well, thank you.
This season of Building for Better Living brought to you in part by Nancy Allison, Shelter Insurance. We're your shield, we're your shelter. Carpet One, beautiful, made affordable.
Want to talk to you about my friends at Carpet One Floor and Home. Did you know they've been in business since 1968? Scott Bradley and his staff have been taking care of my flooring needs for years. Their showroom is the nicest between St. Louis and Kansas City, with over 2,000 square feet dedicated to tile alone. Plus, Carpet One has products that are covered by the beautiful guarantee. If you don't like your flooring for any reason, they'll replace it free. How's that for peace of mind? I'm Paul Pepper, and Carpet One Floor and Home is a friend of mine.
We're Shelter Insurance.
We know you don't stay in business for more than 60 years unless you treat customers right.
We think insurance is better when it relies as much on humanity as it does on technology.
And we know what the weather is like in your area because we live in your area.
Shelter Insurance. For your auto, home, and life. We're your shield. We're your shelter.
Get the insurance coverage you need at the right price. Call Nancy Allison today.
Scout is going through a stage. She loves to flush her toys down the toilet. So when the toilet backed up, I called my mom and said, help. She said, call Mr. Reuter Plumbing. Mr. Reuter showed up on time. They were courteous and professional, nice and neat, and did a great job. I can see why people refer Mr. Reuter. Now it's my turn. Call Mr. Reuter.
Closed captioning brought to you by
on Lamone Industrial Boulevard.
We were up above, as you remember up there, we look at the grounding system. So we have a number 8 ground wire which comes down and attaches to this lug on the top of this 5/8 inch diameter copper ground rod. And so if there's any electrical storm or lightning or anything like that, that system collects electricity. We drive this ground rod 8 feet into the ground, and so the energy is dissipated in the ground there. So that's how we protect this system from lightning and how we protect the occupants of this office or business from any lightning that this might hear. So we have a grounding system that's built per the National Electric Code, which everything has to be built to. And this is a combiner box where these wires, which are in a conduit, they're not in conduit yet, but they'll be in conduit soon. And they go right into this combiner box. We put this surge protection here. So we're protecting against the lightning through the surge protection, and if that would not work or whatever, we still have that grounding rod. So we got backup protection here. So we got surge protection and grounding rod. From here, this is DC power. Right. The DC power then goes underground. We're going to trench in a trench about 24 inches deep across this asphalt parking lot over to the office.
So once that wire gets to the inverter, that's when it's converted to the AC power.
Exactly. I want to show you the brains behind the operation. This is the inverter. This is the brains of the operation. It does many things, but the most simplest way to think of it is it changes direct current into alternating current. So what happens, when we're over here at the combiner box, we're going to run underground. We're going to mount this over in the wall over there. The power will come in here to a disconnect. There's a switch which turns it on and off to the array, comes in here, and from here it goes into the inverter. That's DC power. So DC power has got to be converted to something you can use in your home, which is alternating current power, AC power. So it converts it to 120 volts or 240 volts, whatever you need in your home or your business. Or it could be three-phase power, depending on the type of inverter and the type of energy that you need in your business or your home. So it has a lot of safety features built into this. And then there's an LED display here, which lets you see what's doing, what the production of the array is, how many kilowatt hours producing, what the voltage is, what the amperage is, what the history is, and those kinds of things. Over 4 years ago, the state of Missouri passed the net metering law. And that law allowed citizens, ratepayers, to connect to the grid. And that's what makes solar energy affordable today. Because you do not need batteries or anything with solar energy.
That used to be the deficiency behind solar power, is the batteries weren't, you just couldn't store it efficiently enough.
Well, yeah, it made solar more expensive. There's more maintenance connected with the batteries. So now there are no batteries necessary, because what we do, Amron will come out and change this meter out and put what you call a bi-directional meter in there. A meter that runs forwards and backwards. So like on Saturday and Sunday when Bill's not here at the office, he's generating a lot of electricity, and that meter's running backwards very fast. It's going back onto the grid, and Amron's selling it to other customers. So that reduces his bill, so then he can get that energy back on Monday, Tuesday, and Wednesday.
Which might end up giving him a credit in some months, and he could have a bill some months, but more than likely either nothing or a credit.
That's right, exactly.
I'm now more aware and see these more and more every day as I'm driving, which maybe it's just because it's brought to my attention, but it looks like this is the wave of the future here.
So yeah, we're very excited about it, Cole. We are.
I'm looking forward to seeing the other applications. I know we're going to check out some that are on a roof. We're going to check some other businesses out. I'm looking forward to seeing how these all come together.
Yeah, and we got solar thermals, solar hot water too, which is another way to use energy from the sun, which has been around a lot longer than solar electric, but it's also a very viable use of solar energy, solar hot water.
I know also that you completed this particular cabinet from design to layout to finished product in about 3 hours, is that right?
Yeah, that's correct.